Okay, so I wanted to talk just very briefly about the theory of texture baking and how it might apply to your scenes. Some of you guys might be using ZBrush. I'm not requiring that in this class, but certainly you can model at a high poly level just in Maya and then also have a low poly version of that. So just using this plane, I'm going to duplicate it and move this original one to a separate layer so that we can get it out of the way. Now on this one, I will go to Mesh, Smooth, and I want this to be, let's say, 20 subdivisions. Can only go up to 4? Wow. Come on, Maya. I want this to have a UV boundary of no interpolation. I want sharp edges and corners. And this should divide this without actually smoothing any of it. Alright. Right now I'm just going through and trying to make this into something where we have some geometry on what might be called a low poly version of this, or a high poly version of this, to bake onto our low poly version, which would be the one that we just hid. So perhaps I select some of these. And I'm just creating some interesting detail that might be baked out. You can see maybe this is a wall panel of some sort. You can use the multi-cut tool to add some extra divisions. Just freehand making something that perhaps has some interest to it. Right? Extrude this down. Going to extrude this so that this ends up being like an overhang type thing. Maybe these are. Just a little bit inset, a little bit up, a little bit down. A little bit in, a little bit up. This is a good way to get greebles, which is the artistic term for just small fine details that can give a sense of scale. So one of the main ways we see greebles is something like Star Wars. Woo. Cool stuff, right? We have a sense of this being very, very large based off of all these tiny details and having it on a grid system. So that's what a greeble is. We'll play with greebles more later in the quarter, I think. We're starting to see some greeble, right? I can bevel this a bit. Bevel tool, where are you? Ah. There we go, bevel. And then perhaps on this one, this will be more organic, so just because we're trying to get a sense of this. So I will smooth it again. And then, this is a different tool that you might want to use when you start getting into high poly modeling. I will go to Mesh, Sculpt Geometry tool. And if the tools don't come up, you want to double click this so you get all this info about your radius, your opacity, your whatnot. And the B hotkey still works on this as a brush interface. That's clearly way too strong. So I'll set this to about 0.05 maybe. That's way too strong. 0.0005? I believe when you're using the Sculpt Geometry tool, Control makes it go in the opposite direction, and Shift smooths it. So you'll notice that these faces have just a little bit of wonkiness to them. So this represents our quote-unquote high poly model. And if you were to do this as a model, you might end up wanting to use the quad draw tool later. So imagine this is a more fancy model, and I will represent that with this. No, let's do it twice. So we mentioned the quad draw tool as a way to retopologize, and the way you use this is, first off, you have to set your high poly model as a live surface. Now with that as a live surface, we can use the quad draw tool to start adding points that might represent a low poly version of it. Again, left click places verts, shift highlights it so you can set them. So it's just a nice organic way to work. And it's cool because you can start to see how, even if this is a basic form like that, let's say you had something like a goat horn that loops around, you can start to have hand model geometry that might follow that. Now this is not a complex enough high poly model that we need to do that in this representation, but this is a good idea to understand of how to retopologize stuff. But we have this as our high poly model, and we have this as our low poly model. And next up, we can start texture baking it, which is a means of getting instant information that we can bring into texture with. And oftentimes, it's good for a lot of reasons. The first reason is because it's lazy. You don't have to paint it by hand right off the bat when you bake a texture. You sort of get stuff right away, and it tells you what you need to know. Especially for things like normal maps where it's trying to represent geometry, that's oftentimes the best. Even if you have a bitmap that you can turn into a normal map using, Insane Bump that I showed, and various other tools, baking is actually more accurate to the form because it's using actual 3D data. And the last reason that I think baking is really good is a lot of times you will have seams in 3D, and when you hand paint them, you have to hand fix the seams, and it can be very, very frustrating. There's ways to fix it. Blender has something called external image edit projecting painting, which is really good for that. But oftentimes you just spend way too much trying to fix this seam. And if you bake something out, it baked from an object, so there's not going to be any seams. So now we have to export some of these. And I have my high poly object here. I will export it as an FBX. Export selection. You can click the box, but we want this to be an FBX. FBX is Autodesk's sort of generic format, and it's very standardized across the industry. It's a sort of catch-all that goes between different 3D platforms, and it can have stuff like rigs, animation, more complex data than just a mesh, while still being pretty small in file size. So export selection. Because I am so great at naming conventions, I'm just going to call this small and export it to the desktop like a professional would. Totally great. Woo. And actually that's the large one, so never mind. File, export selection. Large. We'll add this to a different layer. Now on this low poly version, which is just a single plane, the first thing you would need to do is check that you do have UVs unwrapped. Because this plane was just created by the defaults, I think mine did the, yes, it did the mystery monitor. So we can see that this actually does have an unwrap already done for us, which is nice. So we can export this as our small version. So this one we're calling small. Now there's a third program we're going to load, our second program, called Xnormals. And it's just a pretty decent texture baker, and it's really fast. And the main reason we bring this up is that Maya's texture baking is awful. Don't ever use Maya. It's just not something they excel at. And in Xnormal, we're going to load both our low poly mesh and our high poly mesh. One thing that's interesting is there's lots of data that can be extrapolated from a mesh, even if it's just from itself. So I think the z-axis is a good example of this. I'm going to do this in Photoshop so that it gets up on the thing. So while that's loading, under high poly mesh, I will delete this one and add in large from the desktop. Hold on. Apparently I can't see the desktop. So I'm going to move those files into my drive.
I think desktop is network.
Huh?
Desktop is usually network. So when you think of it has issues.
Maybe this looks like a bad idea.
It
Yeah, I'll just move them. Pardon my incompetence as I move these files. Large and small. Copy. Oh, let's go back there. Nice job. Put in there. Just in case, we'll put them in the sauce, maybe. Yeah, I don't want that. What? Let's try that. I hope so. This is high def mesh. We can! So I drag that over, and then under low poly mesh, I'm drag small in. And I'm going to delete this. So low definition mesh is where our target is, and our high definition mesh is where our other one is, our high poly one. There's some stuff that you can look through here that's kind of interesting, which is smooth normals. Might be one that you want to mess with. And this mesh scale is one that we might change at some point, because a lot of baking functionality tries to actually mimic real-world geometry. So ambient occlusion is the best example of this. If you are on a microscopic scale, ambient occlusion is going to be very, very thick and dark. When you're way, way far away, you can look at like the seams of these walls from far away, and there's not going to be a ton of ambient occlusion because it's only about 1 millimeter of ambient occlusion that we're getting. So if you're way zoomed in on that 1 millimeter of ambient occlusion, it's going to be very big. If you're zoomed out, it's going to be small. And so that's where this mesh scale ends up coming into play. Let's look under baking options. And if you want, because there's lots of stuff you can just learn by looking at this stuff, you can just turn all of these on if you want and try baking all of them out. And you'd actually be surprised at how much you can get done by just playing around with these. I like to think of baking as ingredients to a recipe. And so you're getting your normal map, which is your flour, your height map, which is your sugar, your ambient occlusion, which is your Lipitor pill, your bent normal map, which is, I don't know, blah, blah, blah. Ooh, cavity map. Oh. I'm just going to bake those ones for now, and I'm going to set these to 1024 by 1024. And we will set the directory to, oh, I don't know. Sure, week 1. Wow. Now before you bake this, you can actually test to see your scale by clicking in the 3D viewer. And I like doing this because a lot of different programs have very different export scales that are often like 100 times too big or 100 times too small. So if you launch the 3D viewer, you can sort of see these before you even mess around with it. And never mind, it breaks. So I guess we won't. Well, in that case, I guess we'll just bake our naps. Oh yeah, so this is a problem that now we have to face, which is XNormals only allows for tris and quads. So we have to go back to our mesh and figure out where we have this problem. So if I select this mesh again, I think there's a way I can select by similar number of faces. If anyone knows this, let me know. Select by number of edges, so quads versus tris. I think it's select using constraints, which is now off screen.
There's something called cleanup that you can, it'll highlight all the faces that are.
Mesh cleanup.
And you just choose.
Lamina faces. Faces with more than 4 sides. If I hit apply, hopefully that did something. Okay. Yeah, so I fixed all these where I did that funky extra subdivision. Thank you, Emily. So now if I re-export this high poly thing, export selection. Where did I even save this, man? Large? Under high poly mesh, you can right click now and, oh, I actually used the wrong one. So I want the one in the X drive. Alright, let's try this now. And hopefully, oh, look at that! I made a normal map. Oh, it made a cavity map. Made a, what is this? Oh, I don't even know what this is. This is the height map. Cool. How do I click OK? Ah. Cool. And now it does the ambient occlusion. Ambient occlusion I always think is the fun one. You can see how these cavities ended up looking really cool. And I might have put some bars here or something. What is that map? Oh, that's the tangent space normal. Or no. The world normals, as Blender people think of them. And it starts bucket rendering all these. Alright, let's go look at these maps now. Where did I bake these two? Next drive, week 1. Wow. Look at all these cool things. Oh, I have to specify, what is a WDP file? Never mind. So I want to set these to pings. Different files have different things that they do, and there's no right or wrong answer. But it is something that you have to know what's under the hood on these files to know when one is correct or when one is not. A Targa. I think I actually might have one from last week. So the nice thing about a ping as a map is, let's say you have something like some ugly grass, right? You could save this, and the channels are going to be RGB here, and the alpha is actually, it does have an alpha channel, and it's going to be stored right here. There's some good and some bad about that. The good is that we get to work with the alpha right in a way that is contextually sensible to us, which is as a layer. If we were to instead use it as a Targa, or the problem is that when it gets to these small gradations from colorful to not colorful, you might have this problem where it's not sure if there's any color value anymore, because it's deleting that color data as you delete the alpha as well. So you might end up with some hard edges. So that's why you have things like a Targa. And a Targa is useful as an alternate format. Let me see, I think I have some Targa examples in. I think in the nature, images, no, source images, grass. So this is a texture atlas that was partially done. And it's a good example of where a Targa is more useful. In a Targa, we have the problem that we're not working explicitly with our transparency. We have no ability to look at this layer and say, oh, we know where the grass is visible or not. But the benefit is that the alpha is stored on a channel separate from the red, green, and blue. So what happens is we can say, this represents our transparency, and because this represents our RGB, we can make sure that even though this might be 50% transparent, we know that it's green grass. So you won't end up getting this weird edge thing. We're going to talk about that more in in the nature program. This is mostly just wall. This is supposed to be generator. Never use JPEGs, they're lossy. And not like a total douche about that. A beautiful JPEG is worth more than a crappy looking ping. And eventually, you get into files like EXRs, which hold much more dense data and have a lot of value in the CG world. One example is what kind of pixel data they can have. If you click on this little swatch, you'll notice we can go to white, which is 255, 255, 255, to black, which is 000. So that means we only have 255 different variations of white, light to dark, which is really, really kind of pathetic. The human eye has something in the millions. And so an EXR ends up having much denser data, and you can end up having fancy stuff. I'm not exactly sure how EXR store it. I know that our radiance files, which are .hdr, they use the alpha channel as an exponent value. And so, you know, you can have an RGB value of 555, but if it's to the 256th power, that's gigantic, right? So you can end up representing a lot of stuff. Alright, so now I have all these maps generated. And we can start looking at how we might want to go around making a texture. Does this also save as WDPs? No. Oh, it's up one directory. There it is. So next up is just assembling all of these quote-unquote ingredients for our recipe. And because of that, I like to have all the various things I bake in one giant pile. And I'm going to save this as a PSD to just my desktop, because I believe so strongly in good naming conventions and file structure. Don't you do this. Use your Maya directory. Be smarter than your professor. And now we can look at how these look on our 3D object. So here in Maya, let's actually create a new material on this. Assign favorite material. Let's make it a blend. Let's go to our material attributes to look at it. Under the color attribute, I will select a PSD file as my input. Get that. 6 will go into textured mode. And I actually want to see this with no scene lighting going on. So I'll go to lighting, use no lights. All right. Not that one. Use flat lighting. And now we can view this just in terms of the texture. Alright, this is on our high poly one. We want to view it on the low poly. So we can assign that material I just made. Now we can see how this texture starts to look. There's a couple interesting tricks you might want to use. One example of this is using the bent normals texture. And if you look at the channels, you can kind of see something interesting about this. Actually, I'm going to bake something else really fast. Give me one moment. I just want to better show this. This And please don't crash. Alright, this is a little more interesting of an object. In this circle, because it has UV texture editor here, it's right there, already unwrapped. So file, export selection, too small. I'll reload this mesh. Start baking it. Move. So here, I'm using something that's a little more three-dimensional. And I'm doing this just for one reason, which is I wanted to show the height map. Or not the height map. The polygonal normal, the world normal, that's it. Because I wanted to talk about how you can use that for texturing and what it actually represents as a data file. So, I'm going to do this in Photoshop again, so it's recorded. So let's imagine in Photoshop you have a 3D object, right? Eli. Eli.
Yo.
Watch your foot tap.
What's my what?
Your foot's tapping.
Oh, it is?
It's alright. So imagine, if you will, this is a 3D object. And all you want to do is say that it's got sort of this face going like that, going like that. Right? So what I'm trying to say is it exists in 3D space, right? What the world normals do is they create a black and white, or a three-channel image that represents, as you go from here to here, so this is our x-axis, right? Let's just say that black equals leftness and white equals rightness. And so something that is neither pointing left or right is going to be gray, right? And similarly, let's represent our y channel with the gradient representing white as backness and black as frontness. And then finally, anyone want to guess? Oh, it's the up and down. The top is white and black is the bottom. So if something is neither, yeah, I think it actually flips it in baking. So if we were to represent these and combine it into an RGB channel, it's going to look like a funky texture. But so I think that was it right there. So we can actually use this as one of our ingredients in our recipe. So let's open this. Gonna make a butter scream my name. Alright, open that. So I'm assembling all my ingredients now. There's that. There's that. So, what's kind of cool is, you know when they have like video game where they can't afford a lot of lights? A lot of times you have to just paint the light in manually. But we can look at this and actually figure out what we're looking at. So, this channel is probably the front to back channel. Alright, let me see. Let me see on the object where we are. So you can check this in the UV image editor. Yeah. So if you look in the UV texture editor, these faces around here, kind of these black faces over here-ish. Yeah. Okay, so this is the left to right. Yeah, that makes sense. R equals X. So white equals the leftmost part, and black equals the rightmost part. Similarly, the green channel represents the y-axis, which in mine is up, so it ends up being white up here and black up here. So let's save this as a Photoshop document. We'll just call it, yeah, wall bent normals. That's wonderful. Great naming conventions, Oscar. I'll send a blend. I'll find the color. The file, which is in extra. There it is. And the problem is we're just looking at a channel. So let's copy this, or let's select all, copy it, and paste it into a layer actually. And save this. So now if we view this with no lights, or flat lighting, as you often do in a video game, this nonetheless looks lit, right? And we can color this to say it's maybe not totally, or even add in some below lighting, some bounce light by gradient mapping it. I'm totally making up this stuff as I go, by the way, and that is actually kind of something I like about 3D, is you actually get to make up new processes. You should be willing to experiment and play. So I'll go layer, image, adjustments, gradient map. Let's move this over here. Let's make it maybe not totally black. Nice purple shadows. And this hits maybe some green grass, we want to say. So maybe it's a little greener, and it's a little lighter. All of you who have taken my Intro to Drawing class, of course, know that light that is bounced off a surface loses energy, and therefore this bottom light, even though it's bounce lit, will never, ever, ever be more light than this top part, right? The joke is that none of you have taken that class. It's still a little too light for me. That's the joke. So yeah, I watched television back in the day. I used to do it. What did I do? Image adjustment, gradient something. Gradient map. So I said purple, purpley shadows. Purple shadows are always nice looking. Then I don't want to go quite so overlit on the bounce as I was doing it a little more. Oh. And I'm going to pull all the levels actually, the lights and darks both in a little bit, so that there's no pure black from this right now. And the reason for that is maybe we can use this occlusion map to represent darkness with a multiply transfer. So there's with occlusion, here's without. Now here we might start seeing a problem in Maya, which is that Maya is using something under the hood to translate this Photoshop document into a ping under the hood, which then goes on there. And a lot of times it doesn't know what's going on with these layer mode transfers. So if you choose something really weird like color dodge, let's put this as a color dodge layer. It's not going to really know what to do, possibly. Maybe it does. But just know that you have to be a little careful there. So all these other quote-unquote ingredients are really useful. This normal map, for instance, I will just actually save out as a separate document. Share ping. What?
Does everyone know what normal map does?
I think so. I've talked about how it represents the leftness and rightness of on a pixel level rather than a normal level or a face level. Actually, what am I doing? So let's add that as a channel in here. And this is a good thing to see as an alternative to the PSD network thing we did yesterday, because you can see it as we go step by step. First we add a bump map. We're going to say file. And then we get this node, and we immediately have to say use as tangent space normal. That means it's going to be able to interpret that blue RGB value as XYZ. And then if I click onto that node, I can say where I'm getting that. So now let's try looking at this with default lighting. So here's with no normal map. It's just a flat image. Oh wait, oops. I'll turn on my actual texture first. So here's a flat texture. And now with this normal map, if I instead change this bump depth to 1 or so, you can see how it looks very different. Ooh, normally. And these other textures, you know, I mean, the thing about baking is it doesn't get you 100% there. It pretty much very rarely, if ever, will. But it can get you very far. And even stuff like this, the wall height map, this one, at first, might appear kind of useless, right? But it actually could represent something like a differing material. So maybe like the squares are metallic and the black is like a painted metal. So now we can start using this along with our, going to the internet and just taking photos off CG textures. Ooh. Look at me, I'm a 3D artist. Meta. Galvanize. Galvanize. So we'll do what everyone does, which is you hover and you hit print screen. Oh, there's even better. Let me just paste it over here. Yeah, it didn't work. What's with this weird print screen? I'm actually gonna go to Myang. I feel like there's probably a lot more texture websites out there these days. It's just everyone's really lazy. And
A lot of them cost money.
huh?
A lot of them cost a lot of money.
Yeah, I go to Myang because it's really old and rusty, but it's free and you can just go through it as a straight interface of clicking on the picture you like. So perhaps this one is, I don't know. So fabric. Whee! Yeah, that's too close. Beautiful. Sure, that's pretty good. So let's copy this. And I'll paste it. I'm gonna healing brush out that this one little weird divot. Right? Actually, if I crop this, now I can use offset. This is actually kind of getting off topic, but I like showing it. This is not necessarily the best use of it, but there's this idea of tiling textures, and what you're trying to do is get them, well, actually, never mind. I'll do another tiling texture technique. I'll just go with this for now. This wall height, I will duplicate. I will merge it into an upper layer to make it a separate layer that I can copy and paste as data. And on this guy, I will add a layer mask. Do people understand the concept of masks in Photoshop? Ish? Okay. So now I can paste that in as I thought I could. Maybe not. I'll select one as a channel, and then I'll invert this. So now I have this with a layer mask that says, oh, there's paint here on this. Kind of looks crappy, but whatever. Stop judging me, guys. You can see we're starting to get something out of this that's kind of a thing. And the other thing that I like about this black and white texture is perhaps this represents our specularity. Maybe these upper parts are getting hit by lots of things as they roll around on this ball, whereas the channels below it are sort of not getting exposed to the environment as much. So perhaps I can save this as a specularity map. I think I gotta invert it. Maya does a lot of things weird. One of which is I think it inverts specularity maps. So I'll just call this wall specular. My sort of workflow, usually, and I think a lot of other artists prefer Targa explicitly, and my sort of mental workflow is that if I'm dealing with an alpha channel, use a Targa. If I'm not, why not be able to explicitly see transparency? And so I'll use a ping, because it's not going to matter as much. So let's actually try showing this on a new material, because specularity or reflectiveness is not necessarily easy to understand. And I'm still never sure what does anyone know what the equivalent is in Maya of which of these I'm supposed to map to?
For what?
For what?
Specularity? Is it eccentricity?
Specular color, yeah.
Specular color?
Yeah, I don't know why it's called
That's
that.
so dumb. Everybody's always just making up new words for the same things.
Shiny part.
So, this is an example of a specularity map. This now has a texture that basically says, in some places, this is shiny, and in other places it's not. It's half Boolean and half Lambert. And this is something that you do a lot in 3D to aid the idea of realism, because you don't want uniform specularity everywhere. You might have something like the human face, where actually the whole thing is kind of matte, but there's going to be more oil and shininess on your forehead, on your nose, on your lips, where there's a little spit on it probably. And so you would have to like hand paint that in a face, or to some extent you can get these sort of things extrapolated. But on our example of metal, where perhaps this is different channels, or where perhaps these little squares have paint on them, and they're a little more raised on the normal one, we can see that they would be exposed to damage and getting beat up, and they might have paint on them, so they literally had their shininess painted over, whereas the channels underneath still retain that specularity. So for that, we would go back into this material that we initially had, usefully named Blinn 2. Let's resave my Photoshop file. Got that. And now under specular color, I'll load another file and grab that wall specular that I made. Did you guys see that transition?
Transition.
Oh,
Oh yeah.
The difference between when it does have a light and when it doesn't. And this is something that's good to do, is switch from use default lighting to use all lights, and just to test how your textures are working, just get, I don't know, point light or something. And actually see how this moves across the surface. So that specular highlight definitely shows up on these rivets, these rivulets. Oh, this is gonna bug me. Rivulet. A very small stream. That's kind of accurate. Alright, so everyone get an idea of how baking is kind of cool, and how it creates stuff that you can then throw into other textures. Alright, you can take a break, and then when we come back, I want to hover over you guys and dig into your files and see how you're starting to cry and hate yourself.
So my alien cat started going green and red. On the computer.
I don't know what that means. Were you still doing the update?
No, have restarted already.
So the sink is probably a separate material, right? So you might want to make it a different object. Okay. I would also say the sink might be a more procedural material. Or, I don't know. Yeah, I would separate it out into a separate object.
Maybe into a
Here. Shift right right click. Right click UV shell. You should be able to. So you should be able to select one shell. Maybe not the sink, but of the counters. I can read you look like it's cover over the counter. UV shell. There you go. So now you can separate those into different objects. With mesh extract. Or separate. Maybe it's separate. That's like a separate object. They're both selected. Yeah. Right. Sweet. You might be, but you might not. You'll have to start designing the material. And a sink is something where you're kind of using the same metallic look over the whole thing, right? So you can use. Okay. Once more people here, I'll talk about tiling textures. I would start by just getting a metal looking material, and you're probably going to have some sort of brushed metal texture for the normal maps, but you might not even need a different color. Just a straight gray material might work for it.
Let's see, if I was to say this was a problem, how would I?
If it was a problem, what I would do is, it's one of those problems that maybe you're trading size usage for less distortion. And so what you would do in that case is perhaps select the bottom faces of that. Like the faces on the bottom of the sink. Yeah. And now in the UV texture editor, you might scale those down individually. And that should, if they're connected to those other faces, hold them in. So now you can say move them so that these faces are over here and these ones are over there. What I would do for that is there's sort of a workflow to.
But when you're making the UV or something like there's no way to avoid that.
Yeah. Yeah. So you might do something like that, get that one in place, deselect it, and then get these ones in place. And it's not a perfect distortion, but it is a better distortion, perhaps. Oh, yeah. Very complicated. Is yours? That's pretty cool. You got all your unwraps? The solitary laser, right?
Yeah. So is there a way to switch?
Yes.
Because I was just trying to find it.
I think you have to set it to shitter. Also, I'd have to double check it. There's a way to have it be an object with a material that actually likes it. And I think for that case, if you were to do that, that means you're going into mental ray. Are you okay with that?
Yeah.
Okay. So I think what you end up doing is, let me start off by getting into mental ray. So let's just have an object. So you right click, assign new material. And in my case it brings it up off screen. But under mental ray, I think the one you want is it might be in, I might have material X passes, but I might be wrong here. It might actually just be a surface shader. And then under preset,
So, which shader did you choose?
material X, and then I believe what you end up wanting to turn up is, I might be wrong. Hold on a sec, I gotta look that up. Wow. So now I'm getting a different problem, which is I think all my rendering things are off site. Good name connection. Hold on. Now I'm not even getting a render window. Oh. Yeah, let me pause open broadcast there.